Hi everyone. So welcome back to the database module. So I'm going to be taking you for the rest of the semester, and we're going to go through some topics that relate to, I suppose, the administration of the database more so than the design, which I've kind of been focusing on with Mary over the last few weeks. So this week, to begin with, we are going to talk about database security. We will also continue working with MySQL Workbench to look at how we can create indexes and triggers, and also then users within our database and how we can grant privileges to those users and then revoke privileges if we need to as well. Next week then we're going to talk about backup and recovery. So how we can back up our databases, and obviously that's a very good thing to know as you start the implementation of your assignments as well. The following week then we'll talk about transactions and transaction management, and for the last couple of weeks then we'll have a look at NoSQL databases, which are a different type of database. So we just kind of want to give you a bit of exposure to that as well, as the kind of final piece of the module. So in relation to the assignments, before we start, we have received all of your assignments, so thank you very much. We are going to have a look at them over the next week or two, and we'll get back to you individually with feedback about them. So we're not going to give an exact grade at this stage, but we'll just be giving you some feedback to tell you basically if you're on the right track with your database design that you've done. If you need to make any changes before you start implementing it, we'll let you know, basically. A lot of the time people come up with great ER diagrams, but that are maybe very big, and when it comes to implementation, we might kind of advise you to either, focus on one part of it, or if it is a smaller one, we can tell you where you need to expand it and stuff as well. So you'll hear from us on that in the next week or two. Okay, so to start into database security then. So first of all, we'll just talk about why it's needed and why it's important. We'll also talk about some of the types of threats to databases that can commonly occur. We'll have a look at some of the countermeasures against those threats. We'll talk about security then specifically as it relates to the web, and then some other considerations as well. Okay, so first of all, why we need to think about database security. This is a thing that we probably often hear things about in the news and things like that, data's been stolen, or there's been another breach of data from a particular site or whatever. So you do hear these kinds of stories a lot. So data security is a big issue, and it's a resource, I suppose, like any other resource that an organization can have. So with that, it has a financial value associated with it. So we need to kind of secure that just like we would any of the other resources of the organization. We'll talk then about some of the countermeasures that we can take to make sure that we do secure data. We'll also talk at the end a bit about GDPR, which I'm sure, again, you've all heard of in the last year, especially. When you're storing data on users, we need to make sure that the data is secure, and there's legal requirements to do that now as well. Okay, so first of all, some of the types of threats to data that can occur. So a threat is basically any situation or event, either intentional or unintentional, that will adversely affect the organization, the system, and the data within it as well. So yeah, a lot of times it can be intentional, maybe a malicious attack, but probably more often it's unintentional consequences. So things like backups failing, or just human error, or data that's been lost in some other way. So we need to secure against all of those different threats. So the types of threats you might commonly see are things like theft and fraud. So obviously those aren't malicious. So we're talking there about data that's been stolen or fraud if you have employees within the organization that either intentionally or unintentionally cause losses of data. Obviously, any threat to data then can result in a loss of confidentiality. So that could bring up a number of issues. Obviously, if we're storing information that belongs to users, like I said, we have a legal requirement now to make sure that that data is secure and kept confidential. So there's that reason to do it, but there's also if it's business information, I suppose, that we need to keep secure so that we stay competitive. So it might be, I suppose, information secrets that you don't want other businesses to know. Loss of privacy then is where anywhere that data privacy has been compromised. In terms of integrity, data integrity is where we want to kind of make sure that all of the data that we have is consistent and kind of staying correct. So we'll talk about some examples of that as well. And lastly, availability. So generally we want to make sure that our database is available to be used at all times. You can imagine this more so in, say, an e-commerce scenario where a loss of availability is a big deal, because as long as your database is not working and not available, people can't use your, let's say if it's a web application, can't use your application to buy products. So we usually want to ensure availability as much of the time as possible as well. So some of the threats then that can occur, there's a lot of information on this slide, so just to kind of go through it in a maybe clockwise order there. So some of the threats can be relating to hardware. So as it says there, fire, flood, bombs, all those kinds of things we need to think about. When you hear database security first, you might just think of just the database and the DBMS and how you're going to secure that. So you probably think straight away of passwords and maybe encryption and things like that. But you do need to think about the hardware as well. So if there's a flood, is the computer that your data, the server that your data is stored on, is that actually secure from fire or flood or whatever it is? Power losses and surges are mentioned there as well. We'll talk about a few mechanisms in this lecture that you can use to kind of mitigate some of these risks. So some of those are having backups in different locations and things like that. In terms of the DBMS then itself, we need to think about the security mechanisms for that as well. So again, like I said, that might include passwords. We'll also talk about different privileges that we can give to our users as well. So we can make sure that users, I suppose, only see the information that they need to see, and that unauthorized users can't get access to our database. In terms of the communications networks, then we also need to think about whether they're secure. So if we have a database that's been used in multiple different locations, or again, if it's a database that we're using as part of a bigger website, then obviously the information is going to be sent over a network. So we need to think about the security of that as well. So that might be network security and also web-based security as well. The few elements here at the bottom then, so users, our programmers and our database administrators there as well. The people involved all come into it as well. That's one of the biggest areas that I suppose might be overlooked a bit, because like I said, we kind of tend to think of maybe the software first and the hardware and the network, but the people who are using the database are just as important to consider. Because most data losses do occur because of some kind of human error. So we kind of need to make sure that, first of all, I suppose that the correct training is in place for anyone who's going to work with the database or use the database. it mentions here as well things like programmers or operators. If we have staff that we can't trust, I suppose they can do things like create trapdoors in the database, or in programs that interact with the database. So hiring policies probably need to be considered there as well as staff training and so on. So the database administrator should be taking all of that into account as they're coming up with policies and procedures for use of the database. That might be things like, setting a password policy for users, and yeah, those kinds of things. Okay. And just to say then on the environment that people might be using our database in, it can have all of these different elements in it. So this is an example of a multi-user computer environment where we have different users. So these are our users here, these remote clients. So they could be in any location, and they are interacting with the database over a network. So in that case, there's going to be probably a few different things that need to be in place so that that interaction is secure. So we'll be looking at having encryption between the client and the network, probably also a firewall. And then the DBMS server itself should have authorization and access control on it. We'll talk about authorization and access control now in a second. You can see here, you can have some local clients as well. So if your database server and your users are in the same location, it's a little simpler, but like it shows here, I suppose anywhere that there's people interacting with the database over a network, there's going to be a few extra layers there. Okay. Right, so some of the countermeasures then that we can take to mitigate some of those threats. So we'll talk here about authorization, access controls, views, which I think you looked at with Mary last week in your SQL lab. Backup and recovery, which actually we'll be talking about in a bit more detail next week. Integrity, encryption, and RAID technology. So first of all, authorization. Authorization is basically, I suppose, granting rights and privileges to the database. And it can be done in a number of different ways. So I suppose there's the initial authorization, which is basically kind of creating a user who will use the database and giving them access to the database. We'll be doing this in the labs this week, where you create users for your databases, and then you'll be able to use the database as those users. You'll see, obviously, like when you log in at the moment, you probably put in the root user and the password for that. So you can create new users with their own passwords as well. We can also then look at the privileges that those users have. So authorization is basically anywhere where we're using some kind of mechanism to check whether the user is who they claim to be. Passwords are one option, but there's also other things like key cards if we're talking about getting into the physical location of the database server, for example, or biometrics as well. And just a note on passwords. I'm sure you know this yourselves from practice, but people don't always choose the most secure passwords. I myself don't choose secure passwords at all. I just use the same one all the time because it's easier to remember. And basically, that's what a lot of people do. Or they choose a complex one, but then they write it down and stick it to the desk where they're working. So like I mentioned before, it's really important to put policies in place so that people don't do those things. So, to make sure that users know that they need to choose a complex password, make sure that it's kept secure and not written down anywhere and things like that. Okay, and probably providing some kind of forgotten password thing for when they do forget. Okay, so once we have our users, then we need to think about what access they should have within the database. So your root user that you've been used to working with has access to everything, basically every database you create within MySQL Workbench, and full administrative rights to all of those databases. So normally though, we probably have our users have slightly less privileges than that. So we'll create some today where we'll create a user that just has access to just the library database. And you can also do things like set privileges that the user can only maybe read from the database, not do any updates, and things like that. So most DBMSs provide this approach called direct discretionary access control. So we'll be looking at that today. The statements that you use for that in SQL are the grant command, which gives privileges, and the revoke command, which can take away privileges. Okay, and views. And like I said, I think you talked about views with Mary last week. A view is, as it says there, a dynamic result of one or more relational operations on the base relations to produce another relation. So you're taking your base tables and creating a view from those to show maybe just a subset of the table, or maybe to join a few tables together and make it look to the user like they're one table. In relation to security, views can be useful because it allows you to just show a subset of the information to a user, and you can hide information that they don't need to see. So it could be that we maybe want, let's say with employees, that every employee can see just their own details, or certain people can see employee details but not their financial information or things like that. So yeah, so a view lets us do that basically. Okay, backup and recovery then. Like I said, we're going to go into this in a good bit more detail next week. But backups are copies of the database that we keep, so that we make sure that we have another copy if something happens to the copy that we're normally working with. Most of the time we'll have backups, and also try to make sure that the backup is stored in a different location and things like that as well, to make sure that if like the previous slide showed, if there's some kind of fire or flood or something like that, that something happens to our database server that's located in one building, that we have a totally separate copy that we can go to, so we haven't actually lost all the data that's in there. A couple of other things then are integrity and encryption. So integrity is where we're trying to prevent our data from becoming invalid and giving any misleading or incorrect results. So a simple example around that would be if we have a banking application or something like that, and there's a transaction being done where money's been transferred from one account to another account, and let's say there's a power cut halfway through. So we want to make sure that the money hasn't just gone out of one account and then disappeared into thin air and never made it to the second account. We want to make sure that basically the whole thing is done, or neither is done. So integrity controls in our database can make sure that things like that don't happen. So the money either goes in one account or the other, but we're not left with money that's disappeared from one account and not ended up in the other. So yeah, the basically at the end of every transaction that all of our data is correct. Like I said, we'll be talking about transaction management in a couple of weeks, so we'll talk about that in a good bit more detail then. Encryption then. Encryption is using some kind of algorithm that renders the data unreadable. So if anyone gets access to the data that wasn't intended, could be over a network or by physically accessing the data in the database, we want to make sure it's encrypted and that they can't read it unless they have the decryption key. Okay, and lastly then, RAID, another measure we can use here, a computer-based measure, is RAID, so redundant array of independent disks. And it sort of relates to backups, I suppose, because how it works is that we have an array of hard disks that are storing our database. And like it says, most of them are redundant. So we might have it mirrored over 3 or 5 or 7 or however many different disks, so that if one of them goes, then it can switch to another one instead. So most of the time, a lot of those disks might not be doing anything, in some setups at least. So yeah, they're just redundant. However, you can also use it to improve performance. So for example, if you have multiple different disks all storing the same database, we can use RAID to also direct requests to the database to access different disks. So kind of splitting the load for the access to the database over a number of disks. As it says there, disk drives are one of the most vulnerable components that we have in the database in terms of hardware. So that's why this approach is often used, to make sure we have multiple different disks that are storing the same data, but if one of them goes down, then we can access it on a different one instead. Okay. A couple of final countermeasures then, and these ones are not computer-based, but just other things that we need to consider. So the first thing is to have secure access to wherever the data is actually stored. So a lot of the time people, focus on encryption and having great authorization procedures like secure passwords and all that kind of stuff, but don't actually physically secure the place where the data is stored. So that could be a server, and if it is, then obviously it's a case of making sure that the access to the server room is controlled with maybe a key card or something like that. But a lot more often, the ones we kind of hear about at least, are where the data is stored on a laptop and an employee brings it home with them and leaves it on the train or something like that. And then a load of sensitive data has been compromised. So that's something that we really need to put a lot of policies and procedures in place around to make sure, that things like that don't happen. Okay, so I'm going to put up a couple of polls there on Slack to talk about, I suppose, the types of threats that we've just covered, and the countermeasures that we've just talked about as well. So the first scenario here is where, like as you said, a laptop is stolen. This isn't an actual example, but it definitely could be, because you hear about this kind of stuff happening all the time. So a laptop stolen that contains a database with names, date of births, PPS numbers, and blood types of blood donors. So obviously that's a lot of information, sensitive information, more than enough to probably steal someone's identity with. So that would be a big deal if that kind of information was stolen. So first of all, what type of threat to security does it represent, and what countermeasures can be used to prevent against that kind of thing? So like I said, I'll just put up a couple of polls here. So the first one there is just asking you what type of threat to security that is. And with the second poll, then you can choose what countermeasures you would think are appropriate for trying to prevent that kind of threat. and you can take all that apply, by the way. Okay, thanks, Niall, so far. So theft and fraud, yeah. Stolen, yes. Sorry, I thought for a second that I said that the laptop was lost. So I was going to say, I don't know if it's really theft, but yes, you're right. Yeah, theft and fraud, absolutely. Okay. Countermeasures encryption. Yeah, absolutely. If that information had been encrypted, then obviously they could get the laptop, but they wouldn't be able to see what was on there. Perfect. I suppose it also probably also represents a loss of privacy and confidentiality as well. And maybe a couple of other things that we could do to prevent against that are probably authorization, that if it was password protected, that would, further help secure it as well. But I think also the last couple, the physical security, so making sure that the laptop is not in a place that it can be stolen. That might mean preventing employees from bringing laptops home with them, or something like that. And policies and procedures, again, yeah, that kind of falls under that as well. That if we have policies in place to say, okay, we don't bring laptops outside of our secure building, then yeah, that would probably help to avoid that as well. Okay, next scenario. We have a national brokerage firm that's using an electronic funds transfer system to transfer sensitive data between locations. So again, I'll put up the same polls again. This is obviously more of a potential threat than a current threat, but we obviously need to think about what are the kinds of threats that could come up with this kind of scenario, and what countermeasures we could kind of put in place then to mitigate those risks. Yeah. Okay. So thanks, Niall, again. I don't know if you're the only one watching, Niall. But yeah, loss of data integrity, absolutely. Yeah, so if things go wrong with the system like that, we could be looking at a loss of data integrity, and possibly a risk of loss of privacy confidentiality as well, maybe even theft and fraud. So anywhere, I suppose, that we're transferring information between locations, and especially when it's sensitive and financial information, we're going to have to put in place all of the things that you saw on that diagram earlier. So making sure that there is encryption when things are sent across the network, and probably having a firewall in place and things like that as well. Okay. Oh yeah, and you've said encryption there. Yeah, perfect. Okay. Great. Okay. So moving on then to web security. So that kind of leads us into web security. Like I said, when we're talking about information and data that's being sent across the web, we are definitely looking at a more complex scenario. So we're going to have to think about network security, and other things as well. With internet communication, it relies on TCP/IP and HTTP as well. Those are the protocols that were created for transferring information on the web way back when. But they weren't really designed with security in mind, because the web, I suppose, back in its beginnings, would have just been for, sending kind of mostly text-based files and things like that. So maybe security wasn't as much of a concern. Now, when we do so many transactions over networks, including, online banking, making purchases from e-commerce sites, and so on, obviously security is now a big issue. So we need to, I suppose, have lots of different protocols on top of those existing protocols in order to ensure that the data is secure when it's sent across the web. So the things we're trying to make sure of is that first of all, the information is inaccessible to anyone but the sender and the receiver, so that it remains private. So that might be things like we talked about encryption and so on. That it's not changed during transmission, so it's the integrity is ensured, that what's sent is what arrives at the other end, and also, like I said, that both ends of the transaction get completed as well. We also should be able to make sure that we know where it came from, so we can be sure who the sender is. That's authenticity. That we want to make sure that they're genuine, and that a sender can't deny that he or she sent it, non-repudiation. So we want to make sure that we know, especially in situations when we're talking about financial transactions, that we know if we're receiving a message where it came from, that we know, I suppose, who we're sending to as well. So all ends of the transaction need to be secure in that way. So there's tons of different ways that we can do this. This is a module all on its own. I'm not sure actually if you're studying some aspects of security, maybe with Frank and Caroline at the moment, but I'm sure you'll hear about some of these things throughout your course. So some of them are having things like proxy servers or firewalls, digital certificates. So like I said, we can make sure that we know who it is we're interacting with online. Some of these technologies you might have heard of when you're using the web. For example, you might see that your website, actually you should always see that a website you're using where you're logged in, that it says HTTPS instead of just HTTP, so it's secure. You might see sometimes that things say that they're being sent with SSL, so that's a secure socket layer that's used to secure web-based communications. And other types of Java security and ActiveX security as well. There's other things then we can do with the databases themselves that we use on the web, like, for example, using hashed passwords, so that we make sure that the passwords that the users create, if this is like on a website where they can register and log in, say, making sure that the passwords are encrypted when they're stored in the database, And SQL injection attacks are another common one that we probably need to think about when we're creating websites as well. So you might talk about some of that in web development at some stage. And lastly then, other considerations. So other things we need to think about in relation to storing data. And I mentioned GDPR already. This is when it makes me think of all the emails that I got back in May to say, can I keep sending you more spam and that kind of thing. So so it was definitely brought to everybody's attention this year that GDPR came into effect and that there's new guidelines around how people are storing information, our information. So it's EU guidelines around information that's stored on individuals. So it needs to be considered anytime we're storing any kind of information on an individual person. Even if there's no, characteristics like their name in it, if there's anything in there that can tie the information back to the person, it could be user ID or whatever, anything like that. We need to comply with these GDPR guidelines. So the guidelines say that we need to process data in certain ways, and it also specifies legal bases for processing that data. So it's just something that we need to be aware of if we're ever storing information on people. And most of the time, if you have a database, you're probably storing information on customers or something like that. So GDPR says, and this is just a simplified version of what it says. So just to kind of summarize, I suppose, what we need to think about. That the data must be processed lawfully, fairly, and in a transparent manner. So that means that people need to know that we're processing and storing their information. So we need to tell them that and be upfront about it. We can only collect data and store it for specified, explicit, and legitimate purposes. So we need to say upfront exactly why we're storing the information and what it's going to be used for. And the person needs to give their consent for that. It also should be adequate, relevant, and limited to what's necessary. So we only, collect the data and store the data that we need to store. It should be accurate and kept up to date. And GDPR also allows for people to be able to view their own data as well. So we might have to respond to a request from somebody to say, I want to see what data you've stored on me. So we need to be able to make sure that we can provide that if it's asked for. Processed in a manner that ensures appropriate security of the data, including protection against unauthorized processing, accidental loss, destruction, and damage, and so on. So that one is particularly kind of relevant to everything that we've talked about there throughout these slides, where, obviously we want to ensure security and prevent against accidental losses and destruction and all those things anyway. But GDPR now gives us a legal requirement to do all of that. And there's kind of hefty fines if we don't. So more reasons to make sure our database is secure, basically. And lastly then, legal bases for processing data. So like I said, data subjects, that's the people that we're storing information on, they need to give consent for us to process that data. Processing is, it's part of a contract. The data subjects or our users or whatever you want to call them should have the option to withdraw from the contract at any stage. So at any stage they can say, I don't want you to store my data anymore, and then we're obliged to get rid of that information. Okay, and the last couple there, what we're doing with the data is necessary for either the performance of a task that's carried out in the public interest or in the interest of the controller. That's us if we're the ones storing the data. So yeah, so we shouldn't, if we're talking about a particular business, we shouldn't be storing people's data and using it for a purpose that's other than the normal kind of operations of the business, basically. Okay, yeah, so that's kind of it on database security and GDPR as well. We are next going to talk about indexes and triggers and users and privileges. And this is basically the kind of the syntax that we're going to go through for the lab. But we'll take a break first, so for about 10 minutes. So we'll be back at about 20 past 1, and we'll go through the syntax for this week's lab then. Okay. By the way, if there's any questions, just pop them in Slack. Hi. Okay, welcome back. So, like I said, we're going to go on now and talk about the syntax that you'll be covering in the labs this week. So we'll start off by having a look at indexes and triggers, and then move on to talk about users and privileges. Okay. So first of all, I suppose triggers relate to security, users and privileges, obviously also. Indexes, not exactly, but we've just thrown it in here with this for this week. So the reason you might use an index is to speed up access to records within your table. So if, for example, if you find that you're always doing queries on, we're going to do an example now with the book title. So you're probably familiar with your library database. In the book table, the ISBN is the primary key. But normally, you can probably imagine that the users of the database are going to be doing queries based on book title as opposed to ISBN most of the time, anyway. So even though we have the index, which is always, by the way, on the primary key, so there's always going to be an index created on the primary key field. You can also add indexes onto other fields, so ones that are commonly searched for, like, for example, book title. So an index speeds up queries by basically, speeding up access, I suppose, to the records within the table. Okay, usually when you want to look for specific search criteria, that's when you'd choose to create an index. So like I said, it could be a field that you find you're most commonly using for queries. Okay, how we're going to create that then in MySQL in Workbench is using this syntax. So create index, we'll give our index a name, and then specify on and then a table name. Okay, so that's the basic syntax. If you use unique with it, it will enforce that field has to contain unique values. So for the primary key, that's already enforced. So like you're used to by now, the primary key will make sure that every value in every record there is unique. So for example, ISBN, in the case of books, that has to be unique for each different book that we have in the book table. So you might use that sometimes as well. With the case of book title, we probably wouldn't use unique because we might have more than one book with the same title potentially. Okay. With this example, then we are going to, like I said, leave out the unique specified syntax, but we'll just use the rest. So create index, book title, in short for index, on book, and the field we're creating it on then goes within the brackets. So that's title. So just to show you how that one works. Okay. So when you try this out yourselves, just remember to run that use library command first of all. And then we're going to, like you just saw there, create the index, book title, end on book title. Okay, so that creates it on the title field within book. And you can see at the bottom there that's been successful. So then you can show indexes. So this will just show us the indexes that are on the book table. So you'll see with every table, like I said, every table will have at least one index, which is the primary key. So you can see there that's on ISBN. But now we have our additional one that we've created ourselves. So this book title index. Okay, so in the case of our database, it's not super large anyway. So if you want, you can try out a couple of queries there before adding the index and after adding the index on searching for book title. But probably the difference that you'll see is going to be microseconds with a table that size. But you can imagine if it was a table with a bigger size, having the index there then will save more time. So the index it's kind of like it's done, I suppose, half the work of the search before you do the query. So it's already kind of set out different like markers for the commonly searched things. So book titles in this case. Okay, if we want to make changes then to our indexes, we can use alter table to do that, and we can drop the index. So we'll try that one out. And that should just confirm that it's done. If I have a look at it again now, you'll see that index is gone. Okay. Okay. So that's indexes, and removing an index you just saw there. Okay, so triggers then. Triggers can be related to security. How triggers work is we're creating a set of SQL statements that will be carried out when another event occurs. So it could be when something is updated, when a new record is added, or when something is deleted. The trigger is basically the syntax that's going to be carried out when that happens. So for example, it could be, every time a record is deleted, we want to add a record to another table just to say that a delete was done at this time and date by this person. So for security purposes, they can be used like that. Basically, if there's certain things we want to make sure that we know what's happening and when and who's doing what, we can set up triggers to flag those things in the database. In terms of syntax then, how the create trigger statement works is like you see here. So there's a few different parts to it. The first part of the syntax is create trigger. The next part then are 3 different values that we need to give it. So the first one is going to be a trigger name. That can be anything, but we have recommended in the lab that you kind of stick to a kind of a naming convention for it. So that's to say the name of the trigger, the table that it's on, and the type of update that's going to be done. So our example, for example, is going to be before book update. So we are doing, the trigger is going to be carried out before the update's done, it's been done on the book table, and the thing that's being done is an update. Okay. So that's our name. The next thing then is to specify the trigger time. So the 2 options for this are before and after. So we can either carry out the trigger before the, let's say, update is done, or after. And lastly then the event. So the event is either an update or an insert or delete. Those are the 3 options for that one. So in the case of the example we're going to look at in a second, the name of it is going to be before book update, the time is going to be before, and the event is going to be update. Okay, next then we need to tell it what table we're talking about. So that's table name, and then we're saying for each row that's affected, and then our syntax that we're going to carry out when the trigger is executed goes in between this word here, begin, and end. So just to show you what that will look like in practice, we're going to have create trigger before book update, before, so that's the time that we've selected. It's going to be carried out before the update is done. The event that we're talking about is an update. Like I said, that can also be insert or delete. It's on the book table, and for each row we're going to insert a row into another table called book audit. We're going to set action to the string update. We're going to set the ISBN to the old ISBN, the price to the old price, and we're also going to include the current time and date as a timestamp. basically what we're trying to capture here is what was the ISBN before, what was the old price, assuming maybe the ISBN or the price is what's been changed, and we also want to capture when the change happened. But basically everything you have in there between begin and end is the code that's going to be carried out when the trigger is executed. Just to go back a slide there and have a look at the book audit table that we're going to create. So this is the table that we're creating to capture these changes. So this is the one that's being populated whenever the trigger is triggered. Okay, so we'll try that out now. Close this down. Okay, so this is my create table statement here. So I'll just run that, and that's created that table. So you can see now I have this book audit table here. Okay, so this is the create trigger syntax. And sorry, one thing I forgot to say there is about these delimiters. So the delimiter is the code, I suppose, yeah, the current delimiter in MySQL is the semicolon. So it's the thing that tells MySQL that you're done with that particular statement and that it should be executed. Because this semicolon here is obviously part of our bigger statement, which is the create trigger statement, we want to change the delimiter here so that the semicolon isn't the thing that ends the statement anymore, that it's now this double dollar symbol. Okay, so that changes the end statement delimiter to this double dollar symbol. So now when it reaches this point, it'll keep going until it gets to the end and the statement ends here. This line here, delimiter semicolon, is resetting the ending delimiter to be the semicolon. Okay, so we need to include those as well. Okay, so we'll run this statement. It should tell us there that it's created the trigger. To see triggers that you've created, you can use the show triggers command. So I'll just run that as well. Okay, and I can see my trigger now is there. Okay, so my trigger before book update, and you can see there it's showing what event it's being done on, which is updates, the table it's being done on, and so on. Yeah, the timing as well. Okay. So I might just have a look at my books table here for a second and see the contents that are in there. Okay, yeah, so this is the contents currently of the book table. So what we'll do now, just to see the trigger working, is make a change to one of those. Okay, so the one I'm going to change is the first book there, which is titled JavaScript. The price is currently 45, so I'm going to just change the price to 50 instead. Okay. Just close this. Okay, so this is my syntax to do that. So I'm updating the book table, setting the price. I want to set it to 50, where the ISBN is, and that was the ISBN of the book, by the way. Okay, so I'll run that. Okay, and I should see over here that price has changed to 50. So what we'd be hoping now is that if the triggers work correctly, is that it's created a record in the book audit table. So we'll have a look at that. And we should be seeing, yeah, one record's been created in there. So in there, it's captured the ISBN, which hasn't changed, obviously, in this case. The price, the old price, which it was before, the timestamp that it was done at, and also the action that was done as well. That's the string that we created there. Okay. So yeah, anytime the update's done on any book, that trigger is going to be called. So eventually we'd have a bunch of different records in here, all showing the previous prices of the books in our table. Okay. Right, so we can also drop triggers, and yeah, security we've mentioned already as well. Okay, so to drop the trigger, just to show you how that one's done, is just basically drop trigger and the name of the trigger. So we'll just try that one out now. You can see there it's been successful, so I'll just do the show triggers thing again, and I should see now I have no results, so there's no triggers there at the moment. Okay. Lastly then, yeah, like I said, these can be used for security. So it could be that I want to make sure that anytime a change to a price is done, that it goes into, you know, a table like you just saw there, so that I'm kind of having a record somewhere, a log of all of the changes to price that have been made, so that I can make sure that nothing has been done that wasn't meant to be done, and things like that. Okay. So that's indexes and triggers. If there's any questions on any of this, just pop a message in Slack there and let me know. But if not, we'll move on to users and privileges. So in this section, we are going to create some new users for our database. And then we'll look at how we can grant privileges to those users and also revoke them if we need to as well. So the first part, I suppose, is creating the users. So the create user statement lets you create a user. Like you can see here, it's using the create user syntax. The username then is this part. Then identified by is the next part of the syntax, and then password is the next thing we need to give it. So these two parts here are basically replacing with our user name and their password as well. Like it says here, it doesn't allow you to use all caps for your username. So you can use all lowercase, or you can have the first letter uppercase, but not all uppercase. So for example, we might create a user here called manager, uppercase M, and have it be identified by the word boss. Okay, so that's going to be the manager's password. Yeah, so let me do that before we go into the granting bit. So yeah, I have a couple of lines here already. So this one's going to create the manager user and the boss password. So that shows now that's been done successfully. The clerk user I created earlier. Actually, yeah, so it's telling me that's already created. Okay, so the next part then, once we have created our users, the next thing we can do is to grant them privileges or revoke privileges from them. So the grant statement is the one that we use to grant privileges. Here, how we're doing it is granting all of the privileges. So that's everything, including inserts, updates, deletes, read, and you know, any administrative things that you can do with tables as well. So that's granting all of the privileges on library. Library.star means that it will grant access to the library database and all of the tables within it. So we're using the wildcard to say all tables. To the manager user, this last part here then is optional. So that is to say with grant options. So that means basically then as the manager user, I can grant and revoke privileges for other users of the library tables. Okay, so we'll try that one out. Okay, so that looks like it's worked. In a second, we'll try logging in as these different users and just kind of verify that we do indeed have the privileges that we're supposed to have. But first of all, just to talk about a couple of other things with grant and revoke. So with grant as well as grant all, we can specify exactly which privileges we want to grant to our users. So we might have another user called library clerk, and we want them maybe to be able to insert, update and delete and select, but not do any of the administrative stuff. And you can see there the with grant option bit is left out as well. So we can't, when we're logged in as the clerk, we won't be able to pass any privileges on to any other users. So we're just kind of limited to just doing those 4 things. So let me just run that one as well. Okay. And lastly then, in terms of the syntax, revoke. So revoke is used when you want to take away some privileges. Okay, so in the previous step there, we just granted delete, insert, update and select to the clerk user. So let's say we've decided now we don't want the clerk to actually be able to delete anything. We can use this command, revoke delete, to on student from clerk. So that revokes the delete access on the student table from the clerk user. Like with the previous example, we can revoke a few things at once by saying, for example, update, comma, delete. Or we can do revoke all to revoke all of the user's privileges in one go. Okay, so we revoke this. This syntax here is revoking the delete privileges on all of the library tables from the clerk. Okay, so that'll stop them deleting from any table. Okay. So to see our grants, we have this option here, show grants for clerk. Oh, that's not what I meant to click. Yeah, okay, so here we can see the grants that the clerk have. So they have usage. Usage is basically just being able to log into the database. So they have usage on everything at this percentage symbol is usually used to represent localhost. And also then these are the privileges that we've given them. So select, insert and update on the library tables. You can see delete isn't there, so our revoke delete has worked in that case. And we might just do the same for manager to see what grants they have. Okay, and you can see there the manager has more privileges. So again, the manager has usage, that's the being able to log in and so on. And it also, the manager also has grant all privileges on library. So everything, including the option to grant privileges to other people. Okay, the last bit of syntax there about users is if we want to drop a user, this is how we do it. So drop user clerk. We'll drop our clerk user. I don't know if you can see the very bottom of the output on that actually. So let me just make sure it's all fitting in the window. There we go. Okay, so you can see there that's been done successfully. Drop user clerk shows up down here. Okay. So the last bit we're going to do then is looking at how we can log in as a different user. So far you've probably always just logged in as the root user. And all the things we just did, we were logged in as the root user. So like I said, the root user has full admin access to all of the different databases. So if we want to kind of make sure now that our users have been created and they're working properly and that they only have the privileges that they're supposed to have, we'll try out logging in as the manager and logging in as the clerk and see what things we're able to do within there. Okay, so how we do this in MySQL Workbench is to create a new connection, then put in our details that we've created, our username and our password, and then you should see you're using the database as that user when you see the new connection name at the top. Okay, so we'll try that out now. for manager. Okay, so go to the home tab. Sorry, again, I think you're missing the top bit. Yeah, there we go. So click on the home tab there, so that you see your connections again, and click on the plus to add a new connection. You can see I've made one there earlier for the library clerk, so we'll do this one for the management. So you can give it a name, something like that, management. Okay. The host name and the port number are going to be the same as always. So it's still our local host and the same port that we've always used, 3306 in my case anyway. The username we're going to change to manager, and that was an uppercase M. It is case sensitive for the username as well, so make sure you include any uppercase letters as well. For the password, then click on Store in Vault, and you can put in boss, which was the password we created for manager. Click OK. You can do test connection if you want, and it should say successfully made the SQL connection, and then click OK. Okay, so now you see your management connection there. You can see the manager username on it, and if you click into that, it'll open a new tab here for management. So you know, like I said, you know you're logged in as the manager because you can see this management tab here. In your schemas, you should see now that you're just seeing the database that the manager has access to. So I only see the library database there. If I switch back to this other tab where I'm logged in as the root user, I can see library, I can see my supplier DB, and a few other things there as well. So we do see there that our grants are kind of working correctly. That we have, yeah, we have just the access to the library database in there. Okay, I'm just going to recreate my clerk user because I think I dropped it before. Yeah. So that's just created the clerk user, and just run these few things again. So to give the clerk user these privileges, actually, let me do this as the manager. So that would be a way to check that the manager can actually grant privileges. Don't forget with each one to say use library first. Okay, so as the manager there, you see that I've been able to grant those privileges to the clerk user. And I should be able to revoke privileges from the clerk user as well. So that looks like it's all worked okay. Okay, and so now I'm going to log in as the clerk user, and again, just make sure that I am only able to do the things that I'm supposed to be able to do. So in this one, I'm logged in as the library clerk. Again, I can just see the library database, which is all I should be able to see. So we'll say use library there for clerk. And then try to do something that we're not supposed to be able to do. So we're not supposed to be able to delete, because we've revoked the delete privileges. So if I say delete from book, delete from book will basically just, if it did work, it would delete everything from book, because I haven't specified anything, any criteria here. So it would delete all the books. So obviously we wouldn't want that to happen, but anyway, it shouldn't work, I hope. Yeah, it hasn't worked, and you'll see here this error code which says delete command denied to user clerk at localhost for table book. So yeah, I don't have the necessary privileges to do that as a clerk. Okay, I should be able to do other things like select everything from the book table. So we see that works okay. Okay, So you'll be able to try out all of that in the labs yourselves this week. It takes you through all of that, creating indexes and triggers, creating users and assigning privileges to them, and then also shows you how to log in as the different users. So you can kind of carry out similar steps yourselves, make sure that you can do the things in each case that you're supposed to be able to do, and that you can't do the things that you're not supposed to be able to do. So kind of test it all out. And that's it then for this week. Okay, so if there's any questions on any of that, let me know right now if you have any questions in Slack. Otherwise, I'll be available next Tuesday morning from 9 to 11. I'll be live on Slack during that time, so I can answer any questions that you have then, or feel free to send questions at any time between now and then as well, and I'll try and get back to you as soon as I can. For Mac users, by the way, with creating users and logging in as different users, I think the instructions may be slightly different for you when you connect new connections or set up new connections, sorry. So I'll put up a link for Mac users on this in Slack before you get to the lab, okay? Right, so that's it for this week. So I'll talk to you all next week. Thanks very much.